So today we're going to be looking at the log graphs. All right, so we did all the rules and the properties yesterday. Now we're going to be doing the graphs. The log graphs, you're going to see a lot of similarities from when we did the exponential graphs. But it's almost like it's opposite. So for log functions, you are going to have a vertical asymptote. All right, exponentials had horizontal. So because your asymptote is vertical, the left-right shift is going to move your asymptote. Otherwise, it's going to be at x equals 0. All right, so whichever way you're moving left and right, that's going to move your asymptote. Your initial condition is going to come from the inside coefficient. So the b value and of course your left, right, up, down. So this is kind of confusing, this like point here, but your initial condition for the log is going to come from the inside. Whereas exponential, it came from the very front number, the outside coefficient. You are still going to do your left, right, and up, down shifts with your initial condition. So your C value will shift it left and right. Your D value is going to shift it up and down. But you'll start with the inside number instead of the outside. The outside number is not going to matter. All right, now, one of the nice things about logs is that almost, I won't say always, but 80, 90% of the time, you have growth logs, like where your base is greater than 1. All right, the common log, the natural log, most of your logs is where your base is going to be greater than 1. Rarely do you have fractions. Like if you look at this guy here, rarely do you have them, but you can. So we're going to talk about them a little bit, but I will say most of the time they'll be gross. Alrighty. So on this one, I have my asymptote at 0, 0 for both of them. All right, whether you're a growth or decay, it's not going to matter. Your asymptote's going to be at 0, 0. Your initial condition is going to be at 1. Once again, it doesn't matter growth or decay for the initial condition. Your initial condition will be at 1. And it's going to be 1 on the x-axis, whereas for the exponential, it was 1 on the y-axis. When you are growing, you are going to start low and grow high. And it kind of curves like a banana shape. When you are decaying, you are going to start high and decay low. Still curving like a banana shape. All right, so let's look at some of these attributes. Your domain is going to be affected by your asymptote. So depending on where your vertical asymptote is, that's going to affect your domain. On these guys, they're both going to be from 0 to infinity. But if your asymptote changes or there's a reflection happening, your domain is going to change. Your range for logs is always all real numbers, because you'll go down forever and up forever, no matter what kind of shift you have. Left, right, up, down, reflecting, flipping. Your range will always be all real numbers. The continuity, it is continuous on your domain. So there is a domain restriction, but on that domain, you will be continuous. So whatever your domain is, that's where you're going to have continuity. All right, on my growth log, am I increasing or decreasing? Increasing. What about my decay log? Decreasing. And you're going to see it doesn't always work out that way, depending on if there's like a negative, just like with exponentials, it could affect your increasing and decreasing, depending on the growth and decay. They don't always match up. Okay, there is no symmetry, there's no extrema, and there's no boundness, because there's no asymptote bounding it above or below. All right, so we don't really talk about boundness from the left or right. That's kind of weird. So there's nothing bounding it above or below. So we're going to say no boundness. Of course, we have asymptotes at 0, which could change depending on your left-right shift. All right, so the last thing I want to talk about is end behavior. So on this first graph, as x is going forever to the right, so on this one, as you are going forever to the right, where's your function going? Positive infinity. All right, so normally when you do end behavior, you go all the way to the right and then all the way to the left, but is my guy going all the way to the left? No, it's going to 0. So we're going to say as x is going to 0, all right, not all the way, not to negative infinity, to 0, where's your function going? Negative infinity. All right, so remember with exponentials how one side was infinity and one side was your asymptote for the f's? All right, it's the other way for logs. One of your x's will be infinity, one of your x's will be your asymptote. And then your f's will be infinities depending on where your graph goes. So it's kind of backwards. All right, so on my decay function here, as x is going to infinity, where's your function going?
0.
Negative infinity. And then as x is approaching 0, where's your function going? Infinity. All right, so you're just going to have to kind of sketch your graph and look at your end behavior. But that's how that works. All right, log functions are always pointing to the right unless you have a negative x on the inside. All right, so if the x is negative on the inside, that will flip it over your asymptote. It will not affect growth or decay, it just flips it over the asymptote and you're pointing left. So it's kind of like with exponentials, right? So exponentials are always on top unless there's that negative in front and it flips it over, right? It's the same thing with logs, except logs we're talking about the inside. So normally you're on the right, but if the inside is negative, it will reflect over the y-axis and it will flip it. And we're going to do examples. So, all right, look over here. All right, on example 60 through 63, I want to describe the transformations and we're going to sketch the graph. So on 60, let's do all the transformations first. On 60, what kind of transformation is that? Left 2. All right, what about on 61? What's that 3? Stretch, yep. vertical stretch by 3. All right, go to 62. Now in 62, I'm noticing that my x is negative. There's something in front. So just like all the other functions that we've done, if there's something in front of the x, you have to undistribute it before you start describing your transformations. So we are going to undistribute that x, and I'm going to write it in order so it's a little bit clearer what my transformations are. Does that make sense? I took the negative out. All right, so what is this minus 3 going to do? Right 3. And then what will the negative do? It will reflect over y. Mm-hmm. All right, so the negative is going to reflect over the y, and then that minus 3 will go right 3. All right, and then my last one here, what is that plus 1 going to do? Up 1. It's kind of like writing it as log x plus 1, where that 1 is pushed to the side. So that's going to shift it up 1. All right, great. So I got all my transformations. So let's do my asymptote now. So remember, because your asymptote is vertical, the thing that's going to change it is your left-right shifts. So on 60, where is my asymptote going to be? At negative 2. What about 61? Where would it be? 0. There's no left-right shifts. What about 62? Right 3. So at 3. And what about 63?
0.
At 0. Okay, so once you get your asymptote, the other thing that we need to plot is our initial condition. All right, so with exponentials, your initial condition came from the front, right? On logs, your initial condition is going to come from the inside coefficient. Whatever number is inside with the x, the b value, right? And the reason why it's coming from the inside is because your initial condition is on the x-axis. So I want to know where is it starting on the x, so we're going to use the horizontal guy, not the vertical guy, because the exponentials was y. That kind of makes any sense. All right. So on this one, your initial condition was a 1, but we are going to shift that guy left 2. So normally you would start at 1, but then we're going to go 1, 2, and we're going to go left 2. So my initial condition will be right there. And it follows along kind of that same idea where whatever number's in front of the x there, that's how many away from your asymptote it would be. All right, so on 61, the 1 in front of the x is your initial condition. And we are not going up, down, or left, right, so your initial condition is just going to be at 1. And it would be 1 away from your asymptote. All right, so on this one, my initial condition is going to be the negative. And we're going to move it right 3. So if you think about it, if my guy started here at negative 1 and I went right 3, 1, 2, 3, I'm going to end up right there. Which is negative 1 away from your asymptote. Negative, so it's on the left side. And then on 63, your initial condition is 1, but we're going to move it up 1. So it'll be right there. Still 1 away from your asymptote, but it got shifted up 1. So really similar to the exponentials, you're just finding it in a different spot because the logs are like, they're inverses, so they're opposites. All right, and then the last thing we got to do are my growth and decays, which, like I said, a lot of times they're going to be gross because that's just what we use for logs for whatever reason. So ln base e, that's a growth. So we're going to start low and grow higher. 61 is the common log, which is base 10, still a growth. So we're going to start low and grow higher. 62 is a growth because it's an E, but we are going to be on the left side because it got flipped over. So because it's a growth, we're still going to start low and go high, but we're going to go on the left side. So it's almost like a growth got reflected that way. And then this one is another common log, so another growth, so start low and go higher. Okay, I'm going to do these 4 examples and then I'll be done. So just a couple more graphing questions and then we'll call it a day. All right, so same thing with exponentials as logs. We're going to graph those 3 things: the asymptote, the initial condition, and growth and decay. So the first thing I like to find is the asymptote. The asymptote is going to come from your left-right shift, so it is going to come from the inside. Is that too bright of a color? All right, so my asymptote is going to be at x equals 1. It's moving to the right 1. So your asymptote is going to be at positive 1. All right, then my initial condition is going to come from the number in front of the x, which is an understood 1. So my initial condition is going to be a 1, but remember that's getting moved right 1 and down 2. So normally at 1, right 1, down 2, so your initial condition is going to be right there. And then the last thing is your base. This is a base E. So we are going to grow. So we're going to start low and grow high. So does it look like we are increasing or decreasing? Increasing. All right, go to 66. All right, on 66, where is your asymptote at? Negative 3. All right, then I got to do my initial condition, which is coming from that understood 1 in front of the x. And it's getting shifted left 3. That's the only shift going on as far as the up, down, and the left, right. So normally start at 1, but then we're going to go left 3. So your initial condition will be right there. All right, now my base on this one is what? 1/2. So are we growing or decaying?
Decay.
We're going to decay. So we are going to start high near the asymptote and decay downward away from the asymptote. And am I increasing or decreasing? Decreasing. All right, drop down to 67. Where's your asymptote at? -2. Where's your initial condition at? 1, and then we're shifting it. Left 2. All right, what's your base?
Maybe 10.
It's 10. Now, do you see this negative in the front here? That negative is going to make this 10 become a decay. So what it's going to do is this guy here is going to reflect over the x. So normally what would go like that is going to flip around and go like that. Let me delete all these guys and so that negative is going to reflect it and make my growth look like a decay. All right, so the negative inside isn't going to change that. The negative on the inside is just going to flip it over the asymptote. The negative on the outside is going to turn your growth into a decay. And if you think about your log properties, the numbers in front can pop back up and become exponents. And so when you have a negative exponent, that's when your guy gets flipped around and it changes your growth to be a decay or your decay to be a growth. Does that make sense? So that's why it gets funny with the negative in the front. And are we increasing or decreasing? Decreasing. Alrighty, last one. Now on this one, I'm going to rewrite and undistribute the negative. Can y'all see that? Is that too yellow? I'm getting bored with my colors. All right, so I'm going to rewrite it and undistribute the negative because it's got that number in front of the x, and we don't like finding any of our translations if that guy has been distributed. All right, so once I've taken that negative out, now I can say where my asymptote is, which is -2. Okay, what about my initial condition? So my initial condition is going to be -1, but it's going to get shifted left 2. Which makes sense because your initial condition is -1. It should be on the left side of your asymptote. So having your initial condition be negative is going to flip it on the other side of your asymptote. Now on this one, what is my base? 10. So is it a growth or a decay? It's a growth. So we're going to start low and we're going to grow high. We're just doing it on the negative side. And are we increasing or decreasing? And decreasing, yep. From left to right, it's decreasing. It's going to grow, but it's decreasing from left to right. Do y'all want me to do any more, or y'all feeling okay about it? Okay, on your homework, the first 21 is more practice from what we did yesterday. So more practice on the log rules, so you can get those kind of memorized and down. And then you have some calculator ones that you're just going to type in. And then you've got 4 graphing ones. And then on these 4, you are describing the attributes. You can use a calculator to graph that, though. And then the bottom ones, you are describing the transformations and telling me what the asymptote is. So if you would like to, it says you can use a graphing calculator on 26 through 29. But then the other stuff, the other graphing ones try to do without.